120 minutes of non-stop cooking and cleaning. That's the milestone Tesla Bot Gen 3 has just achieved. Equipped with image-based AI, it can slice vegetables with millimeter precision. The robot can recognize and process more than 50 types of ingredients thanks to its 3D sensor system, while many robots can only handle a single task. So how exactly does Generation 3 carry out this cooking mission? Before we begin, please help us reach 20,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. How can Gen 3 cook and handle kitchen tasks so smoothly? Tesla Bot Gen 3 has just accomplished what everyone thought was impossible: cooking and cleaning the house for 2 hours straight. Equipped with self-learning technology, this robot doesn't just perform tasks, but refines them with every attempt. This is no longer a dream. It's a reality that could completely transform the way we live. One of the most important steps in cooking is ingredient preparation, and Tesla Bot Gen 3 can handle this job with accuracy and flexibility. Equipped with object recognition sensors, the robot can identify and classify ingredients such as meat, vegetables, fruit, and spices, then cut them according to requirements. Its image-based AI technology helps recognize the size and shape of each ingredient, allowing for precise cutting, much like a professional chef. Whether asked to slice onions, chop carrots, or cut meat, Tesla Bot Gen 3 can perform these tasks consistently and accurately, avoiding damage to the ingredients or unnecessary waste. Notably, its cameras and 3D sensors are the core technologies enabling Tesla Bot Gen 3 to detect objects in its environment and automatically categorize them. When preparing ingredients, the robot doesn't simply identify them. It also analyzes their geometric features and dimensions to decide the most suitable preparation method for each dish. For instance, when making pumpkin cream soup, the robot will determine the ideal size of pumpkin pieces, cut them into the correct shape, and place them into the pot for cooking. This not only saves time, but also enhances accuracy and efficiency in the cooking process. Once ingredient preparation is done, Tesla Bot Gen 3 moves on to cooking. With its ability to adjust temperature and manage time, the robot can stir-fry, fry, steam, and even bake food with precision, just like a professional chef. This requires not only precise timing, but also correct temperature control for each dish. Its intelligent temperature control circuits, combined with deep learning AI, enable the robot to recognize the condition of food and automatically adjust the heat as needed. For example, when frying meat, the robot adjusts the pan's heat to prevent burning while ensuring the meat is perfectly cooked, neither too dry nor underdone. Temperature control and time management are key factors that make Tesla Bot Gen 3 effective in cooking, especially for dishes that require advanced techniques. To achieve this, the robot can learn from past attempts, adjusting cooking parameters for the best results. If the meat turned out too dry last time, the robot will reduce heat or frying time the next time to get it just right. This not only improves food quality, but also enhances the robot's cooking skills over time, similar to how a real chef hones their craft. One of Tesla Bot Gen 3's biggest advantages over current cooking robots is its ability to present food beautifully. Most cooking robots today can prepare meals but lack the ability to arrange or decorate them aesthetically. Tesla Bot Gen 3, however, not only cooks but also plates dishes attractively. With built-in aesthetic sensors, the robot can identify the colors, shapes, and sizes of ingredients to arrange meals in a visually appealing way. This ensures that the food is not only delicious but also looks stunning, delivering a perfect dining experience in both taste and presentation, even for the most demanding diners. Beyond cooking, Tesla Bot Gen 3 can also handle other kitchen tasks such as washing dishes and cleaning utensils. One of the most important chores after cooking is dishwashing, and the robot can complete this automatically and efficiently. Using object recognition sensors, it can identify different utensils, from plates and cutlery to pots and pans. Once cleaned, it organizes everything neatly back into cupboards, keeping the kitchen tidy. Importantly, it can adjust washing force depending on the item, avoiding damage to delicate cookware. In addition, Tesla Bot Gen 3 can clean the kitchen, wipe down surfaces, and organize items. After cooking and washing, it automatically sweeps the floor and wipes down countertops, keeping the kitchen spotless and orderly. With its 3D sensors, the robot can map the kitchen, identify areas that need cleaning, and move flexibly to reach every corner without causing accidents. This saves time and increases efficiency, making household chores lighter and far less demanding. Once again, please help us reach 20,000 subscribers. This is important for us to stay motivated. Thank you. How is the cooking self-learning capability of Generation 3? Imagine waking up in the morning, stepping out of your room and no longer feeling the stress of household chores waiting for you. The house is already taken care of. The floor is clean, the kitchen is tidy, the dishes are washed and neatly put away, the trash bag has been replaced, and soft sunlight is shining in. All of this isn't thanks to human effort, but to a Gen 3 robot. So, how can a machine learn on its own and handle tasks like cooking and cleaning? The cooking ability of Gen 3 is not just a pre-programmed feature executed in a simple way. Instead, this robot can learn to cook through videos, much like how humans learn from experienced people. By watching cooking tutorials in a first-person perspective, Optimus analyzes each action, from chopping and stirring to adjusting the stove's heat for a perfect dish. After learning the basics, Optimus stores the knowledge and applies it in practice. It doesn't just copy recipes, but also understands context, adjusting seasoning and temperature to suit each specific dish. Although learning from video is the first step, Optimus 3 doesn't stop there. It can learn from real-world environments and specific experiences in your kitchen. When cooking, Optimus might face situations not shown in the videos, such as missing ingredients or a change in stove temperature. But, instead of failing, the robot adapts and adjusts to ensure the cooking process goes smoothly. This not only makes the robot more flexible, but also helps it improve its cooking skills with every attempt. An important factor in cooking is optimizing the workflow. With its ability to synchronize tasks, Optimus can perform multiple steps at once without interrupting the cooking process. For example, while waiting for water to boil for soup, the robot can prepare remaining ingredients, wash used utensils, or clean the cooking area. This not only saves time, but also makes the process smoother and more efficient. Another key element that enables Gen 3 to handle cooking and cleaning is its fine manipulation of tools and ingredients. Equipped with hands that have 22 degrees of freedom, Optimus can perform highly precise actions, from holding a knife to chop vegetables to adjusting heat while cooking. Tactile sensors in its fingertips allow it to finely adjust grip strength. This enables it to handle delicate tasks like holding an egg without breaking it, or grasping objects gently without causing damage. Gen 3 doesn't just learn from videos in real environments, but can also learn from user feedback. After each meal, you can give feedback. Perhaps the soup was too bland or the salad wasn't crisp enough. Optimus records this information and adjusts the recipe for the next attempt. This allows the robot not only to cook, but to continuously refine its skills over time. With its self-learning ability and optimization of the cooking process, Gen 3 is becoming an increasingly important part of households, especially in cooking and cleaning. Optimus's advanced AI not only enables it to carry out chores, but also helps it learn and improve continuously. Its ability to learn from videos and adapt to real-world environments makes this robot gradually become an indispensable assistant in your kitchen. Have you ever imagined a future where cooking and cleaning are completely taken over by a robot? Could there come a day when you no longer worry about household chores and instead focus entirely on what truly matters in life? Why is Optimus Gen 3 considered Tesla's flagship product in home automation? Since Elon Musk first introduced Optimus at AI Day 2021, his long-term goal has never been just to build a humanoid robot, but to create a flagship product capable of revolutionizing everyday human life. Over the years, Musk has proven that Tesla's technologies are not merely electric machines, but tools that reshape lifestyles and redefine traditional tasks. Gen 3 is the next step on this journey, with cooking and household capabilities that deliver benefits far beyond expectations. Musk has consistently emphasized that the ultimate goal of Gen 3 is to save people time and free them from repetitive chores. Rather than being just another experimental gadget, Gen 3 is designed to become a true household assistant, capable of handling tasks from cooking to cleaning, giving its owners more time for creative pursuits or relaxation. Automating such chores is not only a practical solution for busy families, but also part of Musk's broader strategy to bring tangible value to end users. This is not the first time Musk has set ambitious targets for a product. Just as the Tesla Model 3 disrupted the auto market, Gen 3 is seen as a pivotal step toward transforming how people live and work. Especially in a world increasingly struggling with labor shortages, Gen 3 could ease the burden on individuals, while filling workforce gaps in necessary yet tedious jobs, such as cleaning and cooking. One of Musk's strategic aims is to develop Gen 3 into a key part of the household automation ecosystem. While earlier versions of Optimus were limited to simple tasks like walking or performing basic motions, Gen 3 can cook and handle household chores with a level of precision and adaptability that earlier robots could not achieve. The ability to self-learn cooking and perform complex tasks is clear proof of Musk's serious commitment to home automation. Generation 3's cooking skills go beyond merely replicating recipes. It understands context and adapts to requirements. This robot can learn from cooking tutorial videos and adjust its execution to suit the taste and preferences of your household. Such optimization not only saves time and effort, but also enhances overall convenience. Investing in this ability is not just about usability, but also about expanding consumer appeal, as more families look for solutions to minimize monotonous housework. Gen 3 is not simply another Tesla product. It is a flagship creation that Musk has heavily invested in, meant to become a symbol of utility and automation in everyday life. While Tesla is best known for its electric vehicles, Musk has always pursued other advanced technologies capable of reshaping how people live. Developing a robot capable of taking over basic household duties allows Tesla to expand its influence while delivering a product that is practical and adaptable to real user needs. A crucial part of the Gen 3 strategy is long-term value creation for consumers. While initial production costs may be high, with a target of reducing the price to below $10,000 in the future, Gen 3 has the potential to become more mainstream than ever before. Investments in battery technology, AI systems, and production optimization are key to lowering costs and making the robot affordable for households worldwide. From the very beginning, Musk has made it clear that his vision extends beyond developing electric vehicles or renewable energy solutions. It is about building a fully automated future. Gen 3 is an extension of this vision, automating mundane household chores and freeing up time for more meaningful pursuits, from creative work to family moments. Musk is not only focused on the present, but is also shaping a future where robots enhance entire living environments. Gen 3 is not an experimental prototype, but a practical tool designed to ease workloads, bring comfort, and improve quality of life. Investing in humanoid robots for domestic use is Musk's long-term step toward embedding technology into every corner of daily life, paving the way for a truly automated world. What can the current Optimus Gen 3 actually do for $15,000? Stick around. In the next 30 seconds, I'll show you Tesla's most secret update about Optimus. Before we begin, if you love staying ahead on Tesla and AI tech, hit subscribe now. You'll be the first to know the breaking news. In a recent trial at Tesla's research lab, the Tesla bot demonstrated its impressive capabilities by preparing a complete breakfast, including eggs, toast, and fruit, in just 15 minutes. The process involved washing the ingredients, cracking the eggs, managing the stove, and plating the meal. Leveraging advanced AI algorithms, Optimus can seamlessly adapt to its environment. For instance, if water starts boiling too quickly, it automatically adjusts the heat. If a spice jar is misplaced, it identifies and retrieves the correct ingredient independently. Beyond cooking, Optimus Home is designed to take care of various household chores, including sweeping floors, wiping surfaces, and sorting trash. Tesla reports that the bot's battery is optimized to last up to 20 hours on just a 2.5-hour charge, which is sufficient to complete a full day of tasks. Equipped with high-end sensors and cameras, Optimus can recognize and handle small household items such as cups, chopsticks, and plates, doing so without dropping or breaking them. Additionally, it is capable of performing secondary cleaning tasks like sweeping the kitchen floor and wiping down counters. This impressive functionality is made possible by Optimus's multitasking AI, which continuously assesses the environment to optimize efficiency and minimize the risk of accidents. Tesla engineers highlight that even minor adjustments, like recalibrating grip strength when holding a slippery tomato, are automatically handled by the bot, demonstrating its exceptional dexterity and situational awareness. Tesla underscores that dexterous hands are key to mastering everyday tasks. Optimus Home is equipped with highly advanced hands featuring 22 degrees of freedom and 26 DOF in one arm, allowing it to precisely adjust force and movement. For example, it can handle delicate tasks like peeling eggs, chopping vegetables, or stirring dough with great accuracy. According to Tesla's lead engineer, the mass production of these hands, capable of performing such a wide range of tasks, is 50 times more complex than building a robotic arm for a factory. In a typical family lunch scenario, Optimus Home can open the fridge, select ingredients, cook rice, prepare the main dish, and clean up afterward, entirely without human intervention. This is clear evidence that Tesla is advancing toward creating a robot that can take true initiative in daily family life, evolving from a mere assistant into a fully autonomous participant in household routines. Tesla is planning to scale its production to millions of humanoid robots in the near future, with a vision to increase production to billions of Optimus units globally. With continuous advancements in AI, sensor technology, and robotics, Tesla is well on its way to revolutionizing the way we think about household assistants. In fact, these robots will take care of a myriad of tasks around your home, and all you need to do is spend under $20,000 to own one. Elon Musk and the Tesla team have repeatedly emphasized the diverse range of tasks that Optimus can handle, from simple to complex. It's no coincidence that Tesla confidently calls Optimus the world's most advanced humanoid robot. During Tesla's recent earnings call, Elon Musk revealed that the Tesla Bot 3 is expected to launch later this year with an incredible design optimized for mass production. However, he did not explain exactly how it will differ from the current Gen 2.5 model. What challenges did Tesla Optimus have to go through? Beyond cost and manufacturing, Tesla must solve numerous deep technical challenges for Optimus to operate in human environments. Even for state-of-the-art robotics labs, fine manipulation, grasping varied objects in unstructured settings, is one of the hardest problems. A human hand has dozens of muscles, tendons, sensors, and neural feedback loops. To replicate even a fraction of that capability requires high-bandwidth sensing, precise control loops, compliance, real-time adaptation, and fault tolerance. So Tesla's reported struggle to finalize the hand design is a telling signal. A humanoid moving through human spaces must perceive terrain, obstacles, variable surfaces, dynamic objects, people, context, lighting, and signals. It must plan foot placements, avoid collisions, adapt to changes, and respond to instructions. This is orders of magnitude more complex than operating in the constrained environment of vehicle driving. So the integration of exteroceptive sensors such as cameras and LiDAR with proprioceptive sensors, joint encoders, and force sensors to enable autonomy is non-trivial. Balance, locomotion, and robustness by walking upright on two legs across irregular terrain, climbing stairs, recovering from disturbances, shifting balance while carrying loads, stepping over obstacles. These are extremely delicate tasks. Minor miscalculations or sensor noise can lead to falls or damage. Mechanical compliance, fast reflex controllers, adaptive gait planning, and redundancy are critical. Tesla has published limited data but has shown Gen 2 performing tasks like smooth squatting and dancing. For wide adoption, Optimus must operate for thousands of hours with minimal downtime, withstand environmental factors, temperature, humidity, dust, shocks, and tolerate wear. Mechanical joints, cables, sensors, boards, and actuators all must be tested and made robust. Ensuring maintainability and modular replacement is also essential. Additionally, the control stack must coordinate high-frequency control loops, mid-level planning, high-level reasoning, and finally, interactions by voice and vision. The AI mind Musk refers to must combine perception, world models, planning, adaptation, and high-level decision-making. Tesla's experience in FSD is relevant, but the leap to full-body control and embodied intelligence in varied environments is huge. Finally, Tesla Optimus must be calibrated precisely. Manufacturing tolerances, component variation, sensor drift, and thermal effects must be accounted for. Tesla will need automated test rigs, calibration facilities, diagnostics, and feedback loops to monitor and correct errors. Integration testing of hardware and software in real-world scenarios is inevitable and time-consuming. What tech does Tesla use to make Optimus move silently? Beyond mobility and intelligence, the focus on silence addresses a critical gap in robotics. Traditional robots, such as those using hydraulic systems, often generate noise levels exceeding 60 decibels, comparable to a loud conversation, which limits their use in human-centric environments. Optimus, however, operates at whisper-quiet levels, with peak noise during movement measured at just 25 decibels in recent factory trials, comparable to the rustle of leaves or the quiet of a library. This achievement stems from a holistic design philosophy that prioritizes vibration reduction, material science, and algorithmic finesse, ensuring the robot moves with the subtlety of a shadow. At the heart of Optimus's silent operation are its brushless electric motors, optimized for minimal noise output. Tesla employs specially designed electric actuators with high-precision bearings that reduce internal vibrations and eliminate mechanical collisions. Brushless motors, unlike their brushed counterparts, lack the carbon brushes that create sparking and audible hums, resulting in smoother, quieter performance. In engineering terms, these motors achieve noise levels as low as 20 decibels at idle and up to 30 decibels under load. According to data from Tesla's 2024 prototypes shared in internal reports and echoed in public demonstrations. For context, a standard household vacuum cleaner operates at 70 to 80 decibels, while Optimus's motors are engineered to suppress electromagnetic interference and harmonic distortions that could otherwise produce whining sounds. This is achieved through advanced winding techniques and magnetic field optimization, where Tesla's motors use rare earth magnets to minimize torque ripple, a fluctuation in rotational force that often leads to audible vibrations. In a 2025 test conducted at Tesla's Fremont factory, Optimus Gen 3 demonstrated a 40% reduction in motor noise compared to Gen 2, dropping from an average of 45 decibels to under 30 thanks to these refinements. This low noise profile is crucial in healthcare, where robots like Optimus could monitor vital signs or deliver medications without adding to the ambient cacophony that already plagues hospitals, potentially reducing patient anxiety by up to 15%, as per studies from the Journal of Hospital Medicine. Complementing the motors are elastic joints and damping mechanisms that limit vibrations and impact noises. Optimus is equipped with layers of composite or polymer damping materials that absorb forces and eliminate minor oscillations from joint openings and closures. These materials, similar to those used in Tesla's vehicle suspensions, feature viscoelastic properties that convert kinetic energy into heat, dissipating it harmlessly. In practical terms, this means that when Optimus bends its knee or extends an arm, there's no clanking or thudding, common issues in robots like Boston Dynamics' Atlas, which relies on hydraulics and can produce sounds up to 65 decibels during strides. Tesla's design incorporates rubberized bushings and foam inserts with a damping coefficient of 0.5 to 0.7, effectively reducing vibration amplitudes by 70 to 80% in lab tests. Data from a 2025 simulation published on Tesla's AI blog shows that these dampers cut peak impact noise from 50 decibels in unoptimized joints to just 15 decibels, making movements nearly imperceptible. In a healthcare context, this allows Optimus to navigate bedside without startling patients. For instance, in elderly care facilities, where sudden noises can trigger falls or disorientation, silent joints ensure safe, unobtrusive assistance. Imagine Optimus gently adjusting the patient's bed or fetching water. Tasks performed with the grace of a trained caregiver, but without the fatigue or error-prone nature of human labor. The algorithmic backbone of Optimus further enhances its silence by ensuring smooth, gradual accelerations. Powered by Tesla's AI, the control systems adjust acceleration and torque along continuous curves, avoiding abrupt changes that could generate frictional noise or structural resonances. This is akin to how Tesla vehicles accelerate without the gear-shifting jerks of internal combustion engines. The neural networks, trained on vast datasets from Tesla's autopilot, predict and preempt potential noise sources, such as uneven terrain causing foot slaps. In a December 2024 demonstration, Optimus traversed mulched ground, a slippery, uneven surface, using only onboard sensors and a neural net, processing in 2 to 3 milliseconds, maintaining noise below 25 decibels despite the challenge. This blind navigation, as described by Tesla engineers, relies on proprioceptive feedback to fine-tune gait, reducing ground impact forces by 50% compared to rigid control systems. Quantitative data from these runs indicate a gait efficiency where energy loss to noise and vibration is minimized to less than 5%, allowing for extended operation on a single charge. In hospitals where floors might be tiled and echo-prone, this smooth control prevents the amplification of footsteps, keeping overall sound levels under the 35 decibel threshold recommended for recovery wards. By integrating with environmental sensors, Optimus could even adapt its speed to quieter zones, further tailoring its presence to sensitive areas like neonatal units, where noise above 40 decibels has been linked to developmental delays in infants. The frame and outer shell of Optimus incorporate sound-absorbing and insulating materials, turning the robot into a mobile anechoic chamber of sorts. Constructed from aluminum alloys combined with composite linings that absorb sound, the structure features hollow cavities optimized for resonance cancellation. These materials, with sound absorption coefficients of 0.8 to 0.95, in the 500 to 2000 Hz range, human hearing's most sensitive frequencies, trap and dissipate acoustic energy. Tesla's innovations here draw from its automotive glass technology, where acoustic laminates reduce cabin noise by 10 to 15 decibels. Applied to Optimus, this results in a shell that muffles internal mechanisms, achieving an overall noise floor of 20 decibels at rest. In comparison, the quietest place on Earth, the anechoic chamber at Orfield Laboratories, registers negative 9.4 decibels, but Optimus approaches this in operational silence, with moving parts adding only 10 to 15 decibels. A 2025 review highlighted how these material choices enable noise reduction impossible with conventional approaches, allowing Optimus to operate in echoey environments without feedback loops. For healthcare applications, this means the robot can wheel through corridors or handle equipment without contributing to the 50 to 60 decibel average noise in typical hospitals, which studies show can increase blood pressure and hinder wound healing. Tesla applies ultra-thin coatings that reduce friction coefficients, preventing the grinding sounds that plague older robots. Self-lubricating nanotechnology ensures consistent performance without periodic maintenance, cutting wear-related noise by 60% over 10,000 cycles in durability tests. Data from Tesla's 2025 prototypes shows drivetrain noise at under 25 decibels during full-speed walking, a stark contrast to hydraulic robots like Digit, which can exceed 55 decibels. This efficiency not only prolongs component life, extending operational hours to 20 per charge, but also supports silent, reliable service in healthcare. In operating rooms where sterility and quiet are paramount, Optimus could assist surgeons by handing tools without the distracting hums of traditional machinery, potentially improving focus and reducing error rates by 10 to 20%, as per ergonomic studies. Picture this: the glitzy red carpet in Los Angeles, and suddenly, out of the shadows emerges Tesla's Optimus robot, not just handing out popcorn, but throwing down in a playful kung fu face-off that has the crowd erupting in cheers. It's not some CGI stunt from a movie. It's real, happening right there on the carpet, and it's a glimpse into a future where robots aren't just tools. They're performers, partners, and potentially game-changers in our daily lives. Buckle up. This is going to be a ride through circuits, synapses, and sci-fi dreams come true. Before we begin, if you love staying ahead on Tesla and AI tech, hit subscribe now. You'll be the first to know the breaking news. The Tron Ares premiere, hitting theaters today on October 10th, is not just another blockbuster rollout. It's a deliberate fusion of Hollywood fantasy and real-world AI wizardry. Disney teamed up with Elon Musk's ecosystem, Tesla for the hardware, XAI for the brains, and X for that real-time social buzz. The red carpet transformed into an interactive playground where Optimus units, decked out in sleek black and red paint jobs to match the film's cyberpunk vibe, weren't mere props. They mingled with guests, distributed concessions like pros, and yes, one bold bot decided to pick a fight with Jared Leto himself. In the viral video that's racked up millions of views, Optimus strikes precise kung fu poses, fluid blocks, counters, and even a cheeky mirror of Leto's moves, all while maintaining that eerie, endearing balance of mechanical precision and human-like grace. It's the kind of performance that blurs the line between machine and martial artist, leaving everyone wondering, how on earth does a robot pull off something this dynamic without tripping over its own feet? To unpack that, we have to peel back the layers of Optimus's tech stack, starting with the foundation that's already leagues ahead of where humanoid robots were just a couple of years ago. At its core, Optimus Gen II, the version strutting its stuff at the premiere, is powered by a symphony of hardware innovations that Tesla has been iterating on since the bot's debut in 2021. Forget the clunky, jerky prototypes of yesteryear. This is a machine built for ballet-level finesse in a boxing ring. Custom electric motors with planetary gearboxes that deliver torque up to 20 Newton-meters per joint, allowing for those lightning-fast pivots and extensions you saw in the Kung Fu demo. These aren't off-the-shelf parts. Tesla engineered them in-house, drawing from the same playbook that powers their vehicle's regenerative braking and precise steering. So what is the result? Limbs that move with sub-millisecond response times, mimicking the explosive power of a human kick without the risk of a servo whine or sudden stall. But hardware alone doesn't make a kung fu master. It's the software brain that turns raw mechanics into poetry in motion. Enter Tesla's neural network architecture, the real secret sauce behind Optimus's fluidity. Trained on vast data sets from Tesla's Dojo supercomputer, these networks process visual inputs from the bot's suite of cameras, high-res RGB sensors mounted on the head and torso, feeding into a vision transformer model that's essentially a souped-up version of the full self-driving suite. In the Kung Fu sequence, Optimus isn't following a rigid script, it's reacting in real time. Imagine this. As Jared Leto lunges with a mock punch, the robot's cameras capture the motion at 30 frames per second, feeding it into an end-to-end AI pipeline that predicts trajectories, assesses balance, and generates counter moves, all in under 100 milliseconds. This isn't teleoperation where a human puppeteer pulls strings from afar. Elon Musk confirmed it himself. These moves are AI-driven, learned through imitation and reinforcement. It's like watching a student absorb a master's techniques from video footage, then improvise on the spot. How does that learning happen exactly? Tesla's approach leans heavily on imitation learning, a technique where Optimus watches hours of human demonstrations, think kung fu tutorials, sparring sessions, and even parkour clips scraped from the web, and distills them into probabilistic models. The bot's onboard inference engine, running on a custom Tesla system on chip with tensor cores optimized for edge computing, simulates thousands of what-if scenarios per second. Spatial reasoning is key here. Using LiDAR, light depth sensors, and inertial measurement units embedded in every limb, Optimus builds a 3D map of its environment and body in real time. During the premiere, that meant navigating the chaotic red carpet without bumping into photographers while syncing its pose to Leto's, calculating joint angles, center of mass shifts, and even subtle weight transfers to avoid toppling. Critics might point out it was a controlled demo with a human trainer nearby for safety, but the smoothness? That's no fluke. It's the culmination of over 10,000 hours of teleop data refined into autonomous behaviors, proving that Gen 2 is already outperforming rivals like Boston Dynamics Atlas in everyday dexterity tasks. And let's talk superiority for a second because you mentioned it in the query. Optimus isn't waiting for Gen 3 to flex its muscles. It's already lapping the competition in ways that feel almost unfair. Take Figures 02 or Unitree's G1. Impressive, sure, but they guzzle power like sports cars in a drag race with battery lives under 30 minutes for high-intensity moves. Optimus sipping from a 2.3 kilowatt-hour pack that lasts up to 8 hours of mixed activity, thanks to Tesla's battery tech trickle-down from the Cybertruck. Computationally, it's a beast. The Gen 2 neural net handles 1.5 teraflops of AI processing without cloud dependency, enabling those offline kung fu improvisations. We've seen it fold shirts, sort blocks, and now spar with celebrities, all with error rates below 5%, a far cry from the 30% fumbles of earlier humanoids. This isn't hype, it's hardware-software synergy at its finest, where Tesla's vertical integration from silicon design to fleet learning creates efficiencies others can only dream of. At the Tron event, that translated to a robot not just performing but engaging, handing out snacks with a gentle grip calibrated to human pressure thresholds, all while cracking wise via its text-to-speech module. It's charming, capable, and a tad terrifying, because if Gen 2 can already channel Jet Li, what happens when we crank it to 11? That brings us to the main event, the tantalizing potential of Optimus Gen 3, slated for low-volume production by late 2025 and scaling to factories in 2026. Elon Musk has been teasing this upgrade like a kid with a new toy, and from the leaks and updates, it's clear Gen 3 isn't an evolution. It's a revolution. Start with the chassis. Expect a slimmer, lighter frame at under 50 kilograms, shedding 10% of Gen 2's weight through advanced carbon fiber composites and 3D printed titanium joints. This isn't cosmetic, it's about agility. Scaling is where Gen 3 truly shines, though. Tesla's aiming for 1 million units annually by 2030, priced under $20,000 each, cheaper than a used Model 3 thanks to gigafactory efficiencies and economies of scale. In factories, they'll handle repetitive drudgery, welding, assembly, logistics, boosting productivity by 50% without the fatigue that plagues human shifts. But the home front? That's the sci-fi payoff. Gen 3 could cook meals with chef-level precision, using force feedback grippers to julienne veggies or cradle a baby with a feather-light touch. How can you control Tesla Optimus with this insane feature? Don't click away. In the next 30 seconds, I'll show you Tesla's most secret update about Optimus. Before we begin, if you love staying ahead on Tesla and AI tech, hit the subscribe button now. You will be the first to know the breaking news. The idea of connecting Optimus with Meta glasses may sound futuristic, but the mechanism is surprisingly intuitive. Optimus Gen 3 comes with Tesla's latest onboard AI chip, a scaled-down variant of the FSD hardware platform originally designed for autonomous vehicles. It processes massive streams of visual and auditory data at speeds measured in trillions of operations per second. Meta glasses, on the other hand, are designed to overlay digital information into a user's field of vision, creating an augmented reality interface. When the two systems are linked, the human and the robot begin sharing a common digital environment. For example, a user wearing Meta glasses can point at an object in real life, and Optimus instantly receives a digital marker instructing it to pick up, adjust, or analyze that object. Instead of issuing voice commands or scrolling through an app, interaction becomes as natural as looking, pointing, and moving. The new connectivity promises to overcome one of the biggest limitations in current humanoid robotics: the transfer of intuitive commands. Previously, Optimus Gen 2.5 relied heavily on voice recognition and pre-programmed routines. With MetaConnect, Tesla engineers have demonstrated that users can literally see what the robot sees, thanks to a shared mixed reality interface. This has profound implications for both productivity and daily life. Imagine a factory worker guiding Optimus to assemble parts in real time by highlighting key steps in their own glasses view. Or consider an elderly person at home who can instruct Optimus to prepare tea simply by glancing at the kettle on the counter. The bridge between human intent and robotic execution becomes almost frictionless. The hardware underpinning this innovation is equally impressive. Optimus Gen 3 retains its 26 degrees of freedom per hand, with a redesigned Optimus hand, capable of precision grips down to 0.1 millimeter accuracy. Each finger contains tactile sensors that measure not only pressure, but also texture, enabling the robot to distinguish between fragile glassware and a metal wrench. With MetaConnect, those hours are no longer just about robotic independence. They are about collaborative performance. Tesla has released preliminary tests showing that tasks involving dual human-robot cooperation are completed 37% faster when augmented through Meta glasses than through voice or tablet control. Tesla has also refined the locomotion system in Gen 3. Using lessons learned from the auto industry's stability control systems, Optimus can maintain balance even on irregular terrain, compensating in milliseconds for external forces such as bumps, pushes, or uneven flooring. The robot weighs approximately 122 pounds and stands at 5 feet 9 inches tall, closely mirroring the proportions of an average adult human. These design parameters were intentional, allowing the robot to use tools and spaces designed for people. When combined with AR-guided interaction through Meta glasses, Optimus can adapt to complex environments without requiring expensive retooling of workspaces. A warehouse operator, for example, could quickly train a fleet of Optimus units simply by walking them through the environment while wearing the glasses, marking shelves, boxes, and equipment with digital tags. Another major update for Gen 3 lies in its learning model. Tesla's Dojo supercomputer, originally built for self-driving AI training, now feeds Optimus with vast libraries of movement sequences, object recognition patterns, and environmental simulations. With each interaction logged through MetaConnect, Optimus's AI grows more attuned not only to generic human instructions, but to the specific preferences of its owner. Early pilot programs revealed that within 3 days of deployment, an Optimus training with Meta glasses guidance could master up to 500 unique household tasks, ranging from folding laundry to managing home Internet of Things devices. In a factory setting, the same 3-day learning curve allowed Optimus to support repetitive assembly tasks with precision, reducing error rates by up to 21% compared to baseline operations. Analysts at Morgan Stanley estimate that by 2027, nearly 40% of Optimus owners will also own Meta glasses, creating a de facto ecosystem standard for human-robot collaboration. This mirrors the smartphone app ecosystem revolution, where hardware becomes exponentially more useful once paired with intuitive software. Tesla is also expected to announce expanded industrial pilots. Logistics companies are particularly interested in the Optimus Meta synergy. Imagine a team of human supervisors wearing Meta glasses walking through a fulfillment center, instantly marking pallets, labeling destinations, and highlighting hazards. Optimus units can then execute the tasks autonomously, informed by the AR annotations, while still remaining responsive to real-time corrections. Such systems could improve throughput by 20% without significant investment in new infrastructure. In healthcare, hospitals envision using Optimus as an assistant for nurses and doctors, fetching supplies, monitoring patients, and even helping with rehabilitation exercises, all under the guidance of Meta's visual interface. The potential efficiency gains are enormous, especially in an industry struggling with labor shortages. How can you manage Tesla Optimus's power? Beyond the Meta integration, Tesla has announced additional upgrades in Gen 3. One such feature is the improved power management system. The latest Optimus is capable of regenerative braking during movement, recapturing energy each time its limbs decelerate, much like how Tesla's cars recover energy when slowing down. Internal tests indicate up to 12% longer operating hours thanks to this innovation. Furthermore, the communication system has been redesigned, now supporting ultra-low latency 6G connectivity where available, enabling seamless cloud synchronization with Dojo. Even in offline mode, Optimus carries a 64-terabyte solid-state local memory for task storage, meaning it can continue functioning autonomously for extended periods before syncing. Another noteworthy improvement is in human-robot safety. Tesla has introduced an adaptive compliance system that constantly measures force applied during physical interaction. If Optimus senses resistance greater than safe thresholds, such as when bumping into a human, it instantly relaxes its actuators to avoid injury. Combined with its lighter frame and advanced sensor suite, 12 high-resolution cameras, 6 ultrasonic sensors, and 4 directional microphones, Gen 3 represents a significant leap in safety and usability. These refinements are crucial for consumer acceptance, as no one would want a household robot that poses risks to its owners. Appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Techno Creator family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.